This is lesson 3-6. We're going to write compound inequalities from a given graph solution sets of compound inequalities, and solve compound inequalities with one variable. You will need to copy this information to your notebook paper. The set notation and number lines for and or compound inequality look different than just a single inequality. If it's an and compound inequality, notice how the format of the set notation will look. If it is an or compound inequality, again notice the format of the set notation. Copy these to your notebook paper. For the graphs of and or compound inequality, an and compound inequality will shade to the inside, while an or compound inequality will shade to the outside. Note that the numbers are listed least to greatest in our set notation, and we will have open circles for less than and greater than symbols. Example number 1. Copy the number line to your notebook paper. We're going to write the compound inequality shown by the graph. Notice the graph is shaded to the outside. Therefore, this will be an or compound inequality. First, determine the two sections of the graph. We have the section that is x is less than -4. It is an open circle, so it would just have the less than symbol. Then determine the second section of the graph. We have x is greater than 2. Again, it is an open circle, so it does not have to be equals to. This is the compound inequality shown by the graph. It's the set of all x's such that x is less than -4 or x is greater than 2. You will always see the word or in the set notation for a compound inequality. Let's look at example number 2. Copy this problem to your notebook paper. Notice for this graph it is shaded to the inside. Therefore, the shaded portion of the graph is between the values, and this represents an and compound inequality. We will follow the format of an and set notation. In order to correctly write your set notation, determine each section of the graph, and then we'll put it into the set notation. So the first part of the graph, we have x is greater than or equal to -11. But notice whenever you put that in your set notation, because it's the smallest number, we'll need to flip that around. For the second portion of the graph, we have x is less than or equal to -8. Write your solutions in the set notation. -11 will be less than or equal to x, which is less than or equal to -8. This is the format for set notation of an and compound inequality. Notice we do not see the word and in our set notation. So now we are going to graph solution sets of compound inequalities. For example number 3, copy the problem to your notebook paper. We're going to write and graph a compound inequality for the numbers described. So we have all real numbers between -3 and 3. Because we want to be between -3 and 3, this will be an AND compound inequality. Think about the graphs. An AND compound inequality shades to the inside. An OR would shade to the outside. So for your number line, we're going to go with an open circle on -3 and an open circle on +3. Because it only says we want to be between -3 and 3, we will not include these values. We will now shade the area between these numbers. We will need to write a compound inequality for this solution. If the x is greater than -3 and x is less than 3, it is an AND compound inequality, so use the format for that set notation. Notice for the -3 portion of the set notation, you will need to flip the direction of the inequality symbol to make it match our set notation. -3 is less than x is less than +3. Example number 4. Copy this to your notebook paper. We have all real numbers greater than -5 or less than or equal to -11. Think about the problem and determine, will this be an AND or an OR compound inequality? This is an OR compound inequality. It says all numbers greater than -5 or less than or equal to -11. So make your number line to graph. Since we want greater than -5, we will not include the value for -5. So it's an open circle and we shade to the right. Less than or equal to -11, we can show this as a shaded solid circle on the -11 and shaded to the left. Less than or equal to -11. So now we'll need to write our compound inequality. The shaded portion shades to the outside, therefore this is an OR compound inequality. Remember, it's the set of all x's such that, put your smaller number first, so x is less than or equal to -11. You will include the word OR, x is greater than -5. Finally, we will solve compound inequalities with one variable. Example number 5. Copy this to your notebook paper. You have -3 is less than or equal to x minus 1 is less than or equal to 2. To solve this compound inequality, remember this is an AND compound inequality. You'll first need to write your two inequalities. Be especially careful to know that you do not just split it in half. Some students try to split it between the x and the -1, and that would be incorrect. Go all the way to that next inequality symbol. So we have -3 is less than or equal to x minus 1, and x minus 1 is less than or equal to 2. You'll solve each of these inequalities. So we find our solutions, negative 2 is less than or equal to x, and x is less than or equal to 3. Write your set notation, least to greatest. Notice it follows the set notation format with our number less than or equal to x, less than or equal to our number. Graph the solution on a number line. Show one less than your smallest and one greater than your largest. Feel free to skip count if necessary. However, in this problem, negative 2 to positive 3, there's not many values in between, so you can just show every number. It is a closed circle on both the negative 2 and the positive 3. We want to indicate that negative 2 is less than or equal to our x. So this means we're going to shade towards the greater than side. If you need to write this portion of the inequality to where the variable is going to be on your left, feel free to do so. This does shade as we expect it to do so shade the overlapping areas. It shades to the inside for an and compound inequality. We will now check a value in the original problem. Always check with the original problem. I've chosen to check with the positive 1. You could check with any number from the shaded region. When you work it out, we get negative 3 is less than or equal to 0, which is true, and 0 is less than or equal to 2, which is also true. So this does check out. Example number 6. Copy this to your notebook paper. We have 3a minus 2 is greater than 1, or 2a minus 5 is less than negative 5. This is an or compound inequality. You will always see the word or when working or compound inequalities. The first step says to write the two inequalities. You've already done so, so now we're ready to solve. Add 2 to both sides of the first inequality, and then divide by 3. We find a is greater than 1. For the second inequality, you'll need to add 5, and then divide by 2. We find that a is less than 0. Follow the format for a set notation of an or compound inequality. Always put your numbers least to greatest. Some students like to memorize the format. They know that their arrows should be pointing to the outside, just like your graph will shade to the outside. By memorizing the format, it helps you also to remember that your numbers go in least to greatest. Next, we'll need to graph our solution. We have an open circle on the 0 and an open circle on the 1. We'll need to shade less than 0 and greater than 1. So this does shade as we intend it to do so for an or compound inequality. We'll now check a number from the shaded region in the original problem. Because the a is greater than 0, because the a is greater than 1 came from the first part of the inequality, you'll need to check that value in that inequality. So we're going to check 2 in the 3a minus 2 is greater than 1. When you work this out, we find that 4 is greater than 1, which is correct. Next, check a number from the a is less than 0 in the second inequality. Whatever section of the problem that this shaded region came from is where you need to check. We have 2 times -1 minus 5. That gives us a -7, which is less than -5. For an OR compound inequality, you will always have 2 checks. You have 2 shaded regions, so you must have 2 checks. Example number 7. Pause the video at this time to try this problem on your own. Let's check your answers to see how you did. We have 3x minus 8 is less than 28, which is less than 5x plus 3. You should have noticed this is an AND compound inequality. Our first step is to write the 2 inequalities. We have 3x minus 8 is less than 28, and 28 is less than 5x plus 3. To solve, you should have added 8 and then divided by 3. For the second inequality, you should subtract 3 and then divide by 5. Here we have that x is less than 12 and 5 is less than x. Follow your format for set notation of an AND compound inequality. Put your numbers in least to greatest. We have the set of all x's such that 5 is less than x, which is less than 12. Notice our numbers are least to greatest, and the arrows are pointing to the left. Let's check your graph. You should have had an open circle on the 5 and an open circle on the 12, and it does shade to the inside. If you need to flip around your inequality to know which way to shade, feel free to do so. You can always look at the arrow and shade in the direction it is pointing if your variable is on the left. This does shade to the inside as we expect it to do so. Finally, you should check a solution from the shaded region. When you check, you just work it out a step at a time. We find here that 19 is less than 28, which is true, and 28 is less than 48, which is also true. So this checks out. Example number 8. Copy this to your notebook paper and pause the video to work it on your own. Let's check your answers. We have -4x plus 17 is less than or equal to 5, or 6x plus 3 is less than -9. This is an OR compound inequality. You should start by solving each inequality. Notice what we had to do here. First, we subtracted 17. Then, we divided by -4. Always remember the rule. If you multiply or divide by a negative, you have to reverse the symbol for the inequality. Solve the second inequality. So these are our solutions. We have x is greater than or equal to 3, or x is less than -2. Put them in your set notation and check your graph. It should be an open circle on the -2, shaded towards the less than side, and a closed circle on the +3, shaded towards the greater than side. If, in your work, you had forgotten to flip the direction of your inequality symbol, you should have noticed when you get to your graph or even your set notation that something was not working out correctly. An OR compound inequality will shade to the outside. Finally, we'll need to check a solution from the shaded region. We have 2 shaded areas, so we'll have 2 checks. The part that says x is greater than or equal to 3 came from the first part of our problem. So check a number from that area of the graph in that problem. The x is less than -2 came from the second part of our problem. So check a number from that shaded region of the graph in the second part of the problem. Notice both of these do check out. 1 is less than or equal to 5, and -15 is less than -9. This concludes Lesson 3-6, Writing Compound Inequalities, Graphing Solution Sets, and Solving Compound Inequalities.